Alright, in this video we're going to be talking about multiplying polynomials. There are other examples on this that talk about adding and subtracting polynomials. You will not need to know that for the test, but if you wanted to practice them, they are there. It's really just combining like terms. And you have to think back to when we were combining like terms. And then there's also a little bit of distribution in there as well. But we are going to be focusing on multiplying monomials, so that's one term, to polynomials, multiple terms, and multiplying binomials, which is two terms, to binomials, another two terms. All right, so we're going to look at 6 through 8 first. So really this is just distribution. Even as you get exponents and things like that, that part is not changing. We're really just distributing. 5 times x. Here, let me write it like this first. And then plus 5 times negative 4, which is negative 20. That part should not be new because we've been distributing since we started school and prior to that. What's a little different now is when you have terms that have exponents in. The only part that's different is you now have to remember your exponent rules. If you are multiplying like bases, you are adding your exponents. So if I'm multiplying this to each, I'm saying negative 4x squared times x squared. Then the same one from the outside, negative 4x squared times my middle term, negative 5x. Then the same one, the same outside term, negative 4x squared. Let me actually write that down. Times my last term, negative 3. Right? Or this first, negative 4x squared times x squared. I'm multiplying negative 4 and basically 1, so that's just going to be negative 4. And then I have like bases. If I have like bases, I am adding the exponents. So 2 plus 2 is 4. For my second term, I am multiplying negative 4 and negative 5. So that's going to become a positive 20. And then I have like bases. I have x squared, and remember that you always have an exponent of 1 even if it doesn't say anything. So I am adding those exponents, which would be 2 plus 1, so 3. For my last two, I'm multiplying negative 4 and negative 3, which is positive 12. Okay, change colors on me. However, I do not have any more x's. Think about that as x to the 0, because x to the 0 would be 1. If I were to add 2 and 0, it would stay the same thing. So this is not going to change. It's just going to be x squared. In these examples, you shouldn't have anything you can combine, meaning you shouldn't have like terms. So here I have something that's x squared, something that's x to the third. Here I have something that's x to the fourth. None of those are like terms because they don't have the same power or the same number of power. If they did, they would be like terms and we could combine them, but that is not the case. So because that is not the case, this is our final answer. So really we're just distributing, just with more exponents than before. Right? For number 8, same thing. I'm going to draw the lines underneath this time. I'm multiplying 2x to the third times 7x. And since 2x to the third is positive, I'm going to put plus 2x to the third times negative 3. 2 times 7 is 14. And then I have like bases. Remember, I have an exponent of 1 here. So if I have like bases that are being multiplied together, I am adding the exponents. So that would be x to the 4th. Now I'm multiplying positive 2 and negative 3, so that would be negative 6. I don't have any x terms, so this is going to stay the same, x to the third. This is an x to the fourth, this is an x to the third. I cannot combine these two. So this is my final answer.
Right. This is another way to go about multiplying monomials to polynomials, or whatever is inside basically, by using algebra tiles. I know we haven't talked about using algebra tiles since the beginning of the year when we were modeling and simplifying. But if you are a visual person and you want to visually see it, this is how we would do that. We're just going to go through a couple of these, and then we're going to talk about how to multiply binomials using algebra tiles. So first, I have negative 4 times x plus 2, and I want to multiply them together. So I'm going to multiply each of these tiles by each of these tiles. So negative 1 times x would be negative x. Oops, I forgot. I had the negative, or the times 3 on. That would be the same thing again. Negative 1 times x, negative 1 times x, negative 1 times x. Then I have negative 1 times 1. Well, that's negative 1. That's going to be the same thing here. And I can keep dragging and dropping. Right? And it's going to tell you when you got this correct. I think the link I originally had in the notes was incorrect, but I will update it so that it shows this link, so you can go to this link and do expanding brackets and do this practice as well. But after you multiply the negative 4 and the x plus 2, its product becomes this rectangle of tiles. So our final answer is negative 4x minus 8. Now I could have done that just algebraically by distributing as we've done before, but this is just another way to see it. All right, we're going to do one more of these and then we'll get into the algebra tiles, or using algebra tiles with multiplying binomials. So now we have negative 4 and 2x plus 1. Negative 1 times positive x is negative x. That's going to repeat itself. If you are using this site, this times 3 kind of helps a little bit, so you're not dragging and dropping multiple times. Negative 1 times positive 1 is negative 1, so if I click this times 3, it'll put 3 of them there. You just have to remember to take it off. So it rearranged it for me. That means I got this right. So if I count, I have 8 of the negative x's, so negative 8x, and 4 of the negative 1's, so negative 8x minus 4, or if you distributed, negative 4 times 2x is negative 8x, negative 4 times positive 1 is negative 4. Right? Now we have two sets of binomials that are multiplying to one another, and the process is the same. We are still multiplying tile by tile and so forth and so on. So here, the only thing that is different is if we are multiplying something that's like an x, we have to remember our multiplication exponent rule. If we are multiplying like bases, we are adding the exponents. So here this has an exponent of 1, here this has an exponent of 1. If I multiply these two together, I would add 1 and 1 to get 2. So if I multiply x times x, I get a bigger square. This would be the same thing for this x and this x. And then x times 1 is just x. Right? Moving to the next one, 1 times x is just x. 1 times x is x. And then again. And then 1 times 1 is just 1. Right? It's going to be the same thing for the next two rows, so I'm going to turn my times 3 on so I can drag a little less. I think that was one too many. Right? So again, it's making that rectangle my product of everything combined. So x plus 3 times 3x plus 1 is 3x squared plus 10x plus 3. Let's try some more. So now I have 2x plus 3 times x plus 1. Same process. X times x, well, that would be x squared. Oops, I forgot my times 3 was on. This x times this x is still going to give us an x squared. I'll just go down the row. X times 1 is just x. And then we have x times 1, so that's another x. That's another x. 1 times 1 is 1. So this rectangle is more vertical than horizontal, but when I multiply 2x plus 3 times x plus 1, I get 2x squared plus 5x plus 3. Now, this one's going to be a little different because I now have negative x's, right? So if I have a positive x and a negative x, that's going to be a negative, but the exponent rule still applies, so that's a negative x squared. And that's going to be the same thing all the way across. Negative x times positive 1 is going to be a negative x. And that's going to be the same all the way across. And then a positive 1 times a negative 1 is going to be a negative 1. Oh, I forgot 2 of them. This x times these 2 negative 1s give me 2 negative x's. Oops. There we go. So when I put all of that together, x plus 2 times negative 3x minus 2 is negative 3x minus 8x minus 4. Now in a bit I'm going to show you how to do this algebraically if the algebra tiles is not for you. But I just want to show you one other example you might get if you're doing this with algebra tiles. So in this case, we have 2x plus 3 and 2x minus 1. This will usually happen if you have a positive and a negative like this. So here we have x times x, well that's x squared. X times negative 1 is negative x. 1 times positive x is positive x. And then 1 times negative 1 is negative 1. Right? So now it made the rectangle for us, but when you look at this equation, we see that we have like terms that we can combine. So when we combine them, and this is kind of going back to when we were simplifying using algebra tiles, I can cancel out my 0 pairs, or if I have a positive and a negative, I can combine them because they're really canceling each other out. Which just leaves me with 4x squared plus 4x minus 3, which is the correct answer here. We're going to do one more and then be done using the algebra tiles. So now we have 2x minus 3 and negative x minus 1. So x minus negative x, that should be negative x squared and another. X times negative 1 is negative x. Negative x times negative 1, so we have 2 negatives there, so that's going to be a positive x. And then negative 1 times negative 1, again we have 2 negatives, so that's going to be a positive 1. Alright, here, as I'm looking at this, I have positive x's and negative x's, so I can combine those like terms to get my final answer. Negative 2x squared plus x plus 3. Right? So you can multiply your binomials and your monomial times polynomial. So that's 1 times however many is inside your parentheses, or 2 terms times 2 terms. You can multiply it using algebra tiles if that is what you wish. I'm going to show you how to do it algebraically as well.
Alright, so doing this algebraically, I'm going to show you 2 different ways you can go about doing it, and then you will know 3 total ways to do it all together, algebra tiles or these 2 different ways. So you can look at this as we need to distribute, and we can go about that 1 of 2 different ways. We can look at this as I'm going to take everything, I'm going to take this first term and I'm going to multiply it to everything here. So that would be x times x plus 7. Then I'm going to take the second term, which is plus 5, and I'm going to multiply it to everything in that second set of parentheses again. So I'm going to distribute twice. The x to everything and the 5 to everything. I have to remember my multiplying exponent rule. When I am multiplying like bases, I am adding the exponents. Both of these have an exponent of 1. So this would be x squared. X times 7 is 7x. 5 times x is 5x. And then 5 times 7 is 35. From there, I have like terms I can combine. So that would give me 12x plus 35. There's nothing here that I can combine. None of these are like terms. So this would be my final answer. I'm going to show the second way to do this in my next example. So you can distribute it like we just did, or if you want a more, I guess, specified way as to which one you need to do first, you can follow this. We're going to use FOIL, where we multiply the first terms. I put first. Anyway, first terms. So that would be our x's. That would be our first terms. Our outer terms. So that would be the x and the negative 6. Our inner terms, so that would be our 9 and our x. And then our last terms. So that would be, I'm running out of shapes. Let's do this. 9 and negative 6. So doing that all together, multiplying our first term, that'd be x times x, which we already know to be x squared. Trying to keep my color coding. X times negative 6, which would be negative 6x. Our inner terms, so 9 and x, which would be 9x. And then our last terms, 9 and negative 6, which would be negative 54. The last thing we need to do is see if we have like terms, and in this case we do. Negative 6x and positive 9x, if I were to combine those, I would get positive 3x. So listing this all out, I need my variables that have exponents first, then my variables, and then my constants. I have nothing I can combine here. None of these are like terms, so this would be my final answer. This way of distributing is the same as the first way we did it. It's just written differently. So you can really do this either way. We're going to do this 2 more times. I'm going to do number 3 using FOIL. So my first terms would be 5x and x. My outer terms would be 5x and negative 4. My inner terms would be 2 and x. And my last terms would be 2 and negative 4. So 5x times x would be 5x squared. 5x times negative 4 would be negative 20x. 2 times x is 2x, and 2 times negative 4 is negative 8. Putting that all together, after I've combined my like terms, that would be 5x squared minus 18x minus 8. Using my other way of multiplying, I'm going to take 3x and multiply it to everything, and then negative 10 and multiply it to everything. So 3x times 2x plus 1, and then negative 10 times 2x plus 1. So this would be 6x squared plus 3x minus 20x minus 10. I have like terms I can combine. So 6x squared minus 17x minus 10 would be my final answer. So now you have 3 different ways you can go about solving these, either using your FOIL, using the distributing method, or using your algebra tiles. Take those and go and practice some more.